Hey guys, so just how thick is a piece of aluminum foil? Have you ever wondered that? Maybe you've laid awake at night wondering over and over again, how thick is that foil? I want to measure it, but I can't. Because, when you measure aluminum foil and how thick it is, it's really thin. And it doesn't even get to the first line of, say, a ruler. So, how do we know? Well, we're going to help you sleep a little bit better because today we're doing the thickness of aluminum foil lab. And by the end of tonight, you're going to sleep better because you'll know exactly how thick your piece of aluminum foil is. So let's go. So first, you're going to need a couple of pieces of foil. I've given you a couple pieces of foil and they both have a number written on them. That is the exact mass of those pieces of foil, which I found here at school by putting them on a scale just like this and writing down what that piece of foil weighs. So every piece of foil is different and yours are unique to you. So make sure to write that down. The next thing you'll have to do is to use your ruler to measure the length and the width of each of the pieces of foil. Now it's very important that you don't mess with the pieces of foil. They might not be perfectly rectangular, that's okay, but measure it across and up and down the best you can and make sure to take that information. Keep in mind, of course, that to take a good measurement, you need to take every digit given to you by your device plus one more, which is an estimate. So if it's between the markings, you have to note that it's between the markings and give an estimate to how far between the markings it is. Or even if it's right on the line, add that extra zero as an extra digit of accuracy. Once you're done with your two pieces of aluminum foil, set them aside and it's time to move on to your copper wire. You should have a piece of copper wire. Again, it has a mass written on a piece of tape. Leave that on and don't mess with the wire at all, but do take the time to measure as accurately as possible the length of that wire in centimeters. So once you have the length and the width of each piece of foil and the length of your copper wire, you are now ready to do a couple of short calculations and figure out just how thick these pieces of aluminum foil are. Let's go. So the first calculation we need to do is to figure out the volume of our piece of aluminum foil. And to do that, we're going to use the density equation. You may know that density equals mass over volume. So D equals M over V. But I want the volume, so I'm going to rearrange this equation a little bit so that V equals M over D. So if I have a piece of foil that weighs 2.28 grams, I can calculate its volume by putting in volume equals 2.28 grams divided by its density. But how am I supposed to know its density? So if you ever want to know what the density of an element is, well, I guess you could Google it, that's one way. Or you could be a real chemist and go to the periodic table. For example, the two elements we're using in this lab are aluminum and copper. Each box of the periodic table has a bunch of information in it. First, it's got the element's name, the element's shorthand symbol, it's got its atomic number. The atomic number is the number of protons that that element has. Right below the symbol, you'll see some other information. The first one is its atomic mass. That's not what we need for today, but it is a measure of the average atomic weight of the atoms of that element. But then right below that, see this second line down from the symbol, you see this number 2.699, and that's where the density of each element is listed on the periodic table. So aluminum is 2.699, silicon is 2.33, and so on. And these units are grams per centimeter cubed. It's important to note that the densities on the periodic table are accepted values. They've been experimentally determined, and they've been experimentally determined a bunch of times over many, many, many years. And scientists have come to an agreement that to the best of our ability, the density of, say, aluminum foil is 2.699 grams per centimeter cubed. It might be slightly different than that. There's certainly more digits after that we don't know, but we accept that, the scientific community accepts that to be the best truth that we have about aluminum foil to this point, and so we call it an accepted value. So now that we know that the density of aluminum foil is 2.699, and the units for that are grams per centimeter cubed, we can just divide those two values, and the resulting number that we get is the volume of our piece of aluminum foil. And the units for the volume are going to be in centimeters cubed because grams is going to cancel that way. So now that we have the volume of our piece of aluminum foil, now we can get to its thickness. It may be helpful to think of a piece of aluminum foil as just a very, very thin rectangular prism. Something like this, only a lot thinner, okay? And to figure out the volume of a rectangular prism, you take the area of the one side times its thickness. So length times width gives you the area, and then the thickness is what we're trying to find out. So if volume equals area times thickness, we can rearrange that and bring the area down here. So if we know the volume and the area, we take volume divided by area to get the thickness of our piece. The volume that you got before is in centimeters cubed. The area that you get when you multiply length times width is in centimeters squared. So if you take centimeters cubed divided by centimeters squared, 2 of the centimeters goes away and you're left with just 1, and that is the unit that we're going to get for the thickness of our piece of aluminum foil in centimeters. Now, just because we can and because we're a little extra nerdy, we're going to find the radius of our copper wire as well. It's a little different though because our copper wire is not a rectangular prism. You can calculate the volume of the copper the same way as you did the volume of aluminum foil, by taking the mass and its density. But because it's a cylinder, the volume of a cylinder has a slightly different formula. It looks more scary, but I know you can do it. So the volume of a cylinder equals pi times the radius squared times the length. You know the length, that goes there. You know you can figure out the volume, that goes there, and all you have to do is tap your calculator to get the radius of your copper wire. So there you have it, a couple of quick measurements, a couple of taps of the calculator, and just like that, you're gonna be sleeping better tonight, knowing just how thick that piece of aluminum foil is.